So hello everyone again and welcome to my channel. So in here we're going to be looking at the applications of WITTIG reaction. So it's quite interesting how WITTIG reaction is kind of related to the introductory to photochemistry, and mostly how we need to be able to understand how light is being used in some kind of intermediate organic chemistry transformation. So why am I talking about intermediate organic chemistry reaction? In here, if you look at this focus reaction where we have this particular reagent over here being transformed into that due to the addition process of a particular reagent, which I will focus more later on, then we need to be able to go from this particular reactant over here, now a reactant of course, into our final target product. Notice in here that we have some kind of interesting symmetry over here, where you have the hydrogen actually positioned over there away from you overall, but in between this guy and this guy there's a quite an interesting intermediate, and this intermediate has to be influenced by light in order for we to get to this particular final product overall. So before now, let's go at our target goal. Our target goal is to be able to use light to synthesize our particular product called isochromanone, and that is it over here. And also you need to be able to understand how light can be used to promote a cyclization reaction, and this cyclization reaction, it is particular cycle that is being formed over here, and also this needs to be synthesized using a light sensitive highly conjugated molecule via this particular process over here, WITTIG reaction, using photoreactions to produce an isochromanone product. And this isochromanone product needs to be a single diastereomer, which is this particular product overall. So let's look at this full reaction step over here. So our full reaction step over here involves this particular reactant over here, and now what happens next is that we need to react this with carbethiomethanine triphenyl phosphorinone. I know that's really a long name, but I'm just going to give you a shorter name by giving you the structure of it. So the structure or chemical structure is 3 phenyl groups attached to a phosphorus, and then you have a double bond over here which connects it to a particular group overall, which is an ester group over here. So once you react this with that, then you form this particular product over here, which involves the addition and also the formation of an ethyl group, CO2Et. Now what is going to happen now is that this particular reactant over here would then be influenced by light, which is revealed by the HV, and then what you form is an intermediate, which is quite interesting, I would say. We form a double bond over here with an oxygen, and then CET with a double bond over here, and this over here with a double bond over there. So quite interesting that you're going to be forming that, and then once you influence this by light to form this, then there's a kind of a cyclization process that leads to the formation of our final product, and this is the only diastereomer that we're going to ever produce in this particular reaction over here. So next, let's look at our mechanism for this reaction over here. So the mechanism for this reaction includes the following. So our original starting material, which we have over here, is then involved in a particular reaction, which is a winning process. So where in here you have a phosphorus and you have the double bond that is meant to be here. However, this double bond generates a form of an intermediate where the two electrons that are actually involved in the formation of the double bond is being moved over to this particular carbon to form a negative charge on it, and this phosphorus over here has a positive charge on it with its 3 phenyl groups overall. So what happens here is that these 2 electrons will then undergo a nucleophilic attack on this particular carbon over here, and then the oxygen with lone pair then reacts with this phosphorus overall, and then what happens as a result of that is the formation of a 4-membered ring What happens in this particular process? There's a particular rearrangement where you transform a single bond into a double bond, and as a result of that, this particular single bond forms a pi bond over here, and this single bond over here generates a pi bond over here, and what that leads is the formation of this particular product overall, and with a double bond over here, and this particular compound is being cleaved off from this particular bond breaking that happens over here. So what happens next is that you have to notice here that this alkene group over here is quite nucleophilic, so it has the ability to deprotonate, or it has the ability to undergo a particular radical reaction where one of the electron over here then reacts with the electron with the proton over here, and then this particular other electron over here then reacts with this particular one of the electron in the pi system of this particular benzene ring over here. Then the other electron in the benzene ring then reacts with the other electron which was in the alkene group over here. So what that leads is the formation of an intermediate with a loss of aromaticity in this particular ring over here. So this intermediate overall is formed here. So what happens next is that to restore the aromaticity of this particular ring, which is considered to be thermodynamically stable, what we need to do is to undergo or promote a particular cyclization reaction. So this cyclization reaction involves this pi bond over here reacting with this carbon over here, and then this particular pi bond over here then comes back to the ring, and then this particular pi bond over here, which is this alkene group over here, then moves over to the particular carbon over here. So as a result of that, what you generate is your isochromanone product. that is about it for this particular reaction, and this is our product that has been formed over here. Thanks again for watching, and please don't forget to hit the like button, share and subscribe, and see you on my next video. Be smart.